You're listening to The Back 40, the podcast for Ontario farmers, covering topics and issues that matter most to Ontario agriculture. Brought to you by Trillium Mutual Insurance, bringing the ag community together one podcast at a time. I'm the host of The Back 40, Mike Bryan, agribusiness specialist at Trillium Mutual Insurance. Agriculture has changed a lot in the past 50 to 100 years. We've seen a tremendous amount of technology that has come about. And there have been a few things out there that have been a game changer as far as how we've produced food. I remember my dad talking about the first tractor that they got on their farm. And with the extra tractors, now all of a sudden we saw that we no longer needed horses. One of the other game changers that we might have seen, of course, is having our auto steer and our GPS tracking. Things that my grandfather wouldn't understand at all if he saw them, and I'm not sure what he would have thought of them either. But the things that are coming down the road may be more of a game changer than the stuff we've seen in the past. I'm talking today with Professor Scott Shearer from The Ohio State University. Scott is professor and chair of the Department of Food, Agriculture, and Biological Engineering at The Ohio State University. Scott, welcome to the Back 40.
Well, thank you very much, Mike. Happy to be here.
For our listeners, give us a bit of your background as to your travels that have taken you to the chair position at The Ohio State University.
Well, thank you very much. My background in history, I'm an Ohio State University graduate, received all three of my degrees here in Columbus, Ohio. I was trained formally as an agricultural engineer. My interests have always really been in the area of agricultural field machinery. I spent 25 years at the University of Kentucky. It was a great experience. I rose through the academic ranks, became chair of biosystems and agricultural engineering at the University of Kentucky. I was in that position for 4 years and then had an opportunity to return to Ohio State University here in Columbus as chair of the Department of Food, Agricultural, and Biological Engineering. My interests have really always rested with automation in agricultural field machinery, and I'm talking about production agriculture. I'm a corn and soybean type person in terms of my research interests, but mostly machine side of that. More recently, I've done quite a bit of work in the area of artificial intelligence and also kind of thinking about what's going to happen as we begin relegating more and more control and automation, if you will, taking that out of the hands of the human equipment operator and turning it over to automated controls. And so I'm thinking about how these equipment complements are going to change and really how it might change how we look at field crop production. I'm really talking about broad acre crops that could be broadly applied across all, but being that I'm here in the state of Ohio, the focus right now is on corn and soybeans.
So we're used to the idea of automation when it comes to things like factories, where you have a controlled environment where everything's always the same. But some of the challenges that we're going to face in agriculture, of course, is that a lot of our places that we're trying to run this machinery is not a controlled environment. It's out in the field somewhere. So what do you see happening down the road for things like corn and soybean production as far as automation goes?
Well, you kind of hit on this issue of when we mechanized agriculture, and that really came with the advent of the internal combustion engine. And we look at the agricultural tractor today. One of the things I want the listeners to realize in some respects, one of the things that we've done historically is we continue to increase the size of the field machinery. What I'm really talking about is increasing horsepower in tractors. From about 1920 to 1960, there was a modest increase in the largest tractors produced, and I'm really talking about internal combustion engines, spark ignition during that time. About 1960, we had the diesel engine came into its own. And since that point in time, if we look at the largest tractors produced by the manufacturers, we've seen about 850 to 900 pound increase per year in ballasted tractor mass. And I want to remind everybody, as horsepower increases, the weight of the tractor has to increase necessarily so you can take advantage of it and put that horsepower to the ground in case of tillage operations. So farmers know that they need to be timely in their field operations. We've had some challenges, at least here in the state of Ohio, over the last 25 to 30 years in terms of losing the number of days that we can actually perform field operations because of rainfall events. We've also, farmers in the state of Ohio have recognized when they plant their soybeans ahead of corn, there's a little bit better profitability on the farm. And so one of the things I'm suggesting is we've kind of collapsed that planting window, if you will, in the state of Ohio to really 30 days between April 15th and May 15th. And farmers are fortunate enough to get both their soybean and corn crops in the ground. They usually have pretty decent years. Again, farmers in their quest to be more timely buy bigger equipment. And we've kind of been in that vicious cycle now for some time.
That leaves us with some major problems when it comes to things like soil compaction, for example. I know the first tractor that my grandfather bought was an old Farmall A. And I guess that thing to be maybe 2,500 pounds in total. It's a very small tractor. Today, we're talking 250, 300 plus horsepower. Essentially, the tractors look very similar. They're just a bigger model and better style. So where do you see us going as far as going down the road here? You're thinking maybe is that we're not going to see as many of these large tractors?
Well, I think right now everything is kind of predicated on the assumption that you have a human on the piece of equipment operating it. And we know with COVID, it kind of exacerbated this problem of finding qualified equipment operators, especially in rural North America. And again, what I go back to is I know that farmers they're talented business individuals. There's no question about that. They want to be in control of all aspects of their operation. And one of the ways they do that is they buy larger equipment so that they can be the operator of the equipment in the field, making certain that in terms of planting operations, nothing's being missed. Harvest operations the same way. As we continue to move forward, though, I think there is a reasonable upper limit to the size of equipment. Today we have I'm going to say four-wheel drive tractors or quad tracks, four tracks, whatever the case may be, well into the 600 horsepower range, engine horsepower that is. We have class 10 and 11 combines, depending upon which manufacturer, but at least one model being produced by one of the major manufacturers, 790 horse. And so along with that engine horsepower comes the base weight of the machine, the harvest capacity, the header size, and everything else, grain tank size. And so really one of my concerns right now is as equipment increases in size, the real question is what are we doing to the soil profiles? Compaction was a concern back in the 1970s and 80s. USDA had a laboratory and ARS individuals focused on soil compaction in Auburn, Alabama. And that was back during the 70s and 80s when we had those massive 125, 150 horse tractors.
Yep.
So I'm kind of curious why some of the focus has shifted away from concern over compaction. I kind of go back and I look at equipment size, and I want to be careful here because whenever you traffic a field with a piece of equipment, there is going to be some level of soil compaction. But I also caution people to begin thinking about the depth of that influence of compaction today. We have some models to suggest that might be a meter deep into the soil. Whereas in the past, we really only worried about maybe the top 14 to 18 inches. So again, things are changing. I know that farmers, in an effort to realize the harvest capacity of some of the combine sizes today, grain carts have not necessarily gotten better. We have one manufacturer here in the state of Ohio marketing under the Brent label, offering a 2,500 bushel grain cart. And so I just kind of wonder where all of this ends in some respects. And I want to remind everybody what's kind of driving the situation today is farmers need to be timely. Farmers needs to be timely in their operations, and the fact that we still have human operators.
In the future, with the automation that we've seen, I know that one of my neighbors talked about how he could be on social media so much. He said, well, once I turn the tractor around and hit the button, it's locked in. I don't have anything to do for the next 10 minutes. At some point here, and at that time's already here, we're going to get to the point where we don't even need to turn the tractor around. The automation on it will do that itself. At that point, you don't need anybody in the cab. So that time's already here. I know John Deere is marketing this spring, is marketing a tractor that will do that. What implications does that have for agriculture going forward?
Well, increasingly and the manufacturers have been very good at this, and I want to say across the board, they're very good at this. They've continued to take control responsibilities away from the human operator. And so when I think about adjustments to combines, we have cleaning shoes that adjust themselves today. The human interaction or the human ability to set various parameters in terms of the harvest capacity, the harvest quality of the machine has really been reduced. And in some cases, you don't really want the operator adjusting the machine because the machine does a much better job of producing that clean grain sample when it's allowed to adjust itself. And so I look at some of those sort of things you mentioned, end of row turns, the automation of that. And again, that's something that's kind of front and center today. We know that auto steer is an example, at least on John Deere tractors, the bigger ones. It's a base feature of the machine. It's no longer an option. Farmers, when they buy that tractor, it comes with auto steer. And so we're seeing a lot of this technology that maybe 20, 25 years ago, we kind of thought was kind of pie in the sky or kind of futuristic. It's routine on farms today. Yield monitors, combines all come with yield monitors. I mean, it's part of what makes that machine operate. And so as time has gone along, the equipment industry has done a very good job of automating certain features of the machine. And I just talked about a few of those. And again, depending upon the piece of equipment, that there can be more or less automation. But the one thing that remains constant is we still have a human in the cab of the machine. As we think about what's going on, in some respects, that human operator is there to monitor the progress of the machine and really to avoid some of the more catastrophic events, such as collisions that might occur between the piece of equipment in the field. We've all seen some of the high voltage transmission lines where tractors have run into those towers and some things like that. And really, the operator is being kind of relegated to, and I hate to say it this way, but more of a babysitting role than anything in a lot of this equipment. And again, I'm talking about late model equipment.
Mm-hmm. So somewhere down the road, whether it be at 5 or 10 years, we're going to see the operator out of the cab. What implications does that have for the machinery itself?
Mike, I think there's a couple things we need to think about in terms of removing the operator from the field environment. And I want to be careful here because we're going to go through a transition where we're going to move from obviously the operator being on a piece of equipment to the operator being in some remote location, could be in a farm office or something like that. I think we're still going to have human interaction with the machines in the field for some time to come. And really the humans are going to be relegated to kind of a monitoring role, but that can be done remotely if we have good connectivity. And by the way, that operator maybe is monitoring multiple pieces of equipment. So it's no longer one person on a tractor or sprayer or combine. It's going to be maybe one person monitoring multiple machines. The other thing that leads to is what happens to the cost of the machine in the field. And I want to be careful here because we know that as we remove the operator, there's going to be some increased requirements in terms of sensing and control. But the other side of the coin is there's quite a bit of cost baked into a machine in terms of accommodating the human operator. The example I'm going to use is almost all ag tractors today have a cab or an enclosure for comfort, sake of the farmer, and allow them to work extended periods of time. But when I think about that operator environment, we have the means of egress. You got to get onto the tractor, you got to get off, and you have to do that safely. That cab, a lot of times could be suspended, so there could be air suspension. The seat in there is usually an air suspension seat. A lot of creature comforts in that cab. There's air conditioning to keep the operator comfortable, heat for the winter time. When we think about filtration on the cabs, especially sprayers, one of the things we're trying to do is ensure that we're reducing the risk to the operator from being around some of those agricultural chemicals. When you look at lighting on these pieces of equipment, high intensity discharge lighting, now LED lighting, but lighting has really changed tremendously. The cost of that lighting is pretty substantial. A lot of those tractors historically have been styled with the sloping hoods to allow the operator to see out over the front of the tractor. Being able to have that 360-degree view of operations in the field is important. And so when you think about it, once you remove the operator from the piece of equipment, you really remove a lot of cost from that piece of equipment. Again, it's going to depend upon the size of the equipment. Just some example numbers. Today, if you look at the base price of a new tractor, and I'm going to talk about a high horsepower tillage tractor, that base price is going to be somewhere around $1,000, $1,100 per engine horsepower. Okay. What I think is when we remove that, all the things that we add to that tractor to support the operator, we might actually be able to get the base price of the tractor down closer to $700, maybe $750 per horsepower, engine horsepower. And I know that we're going to have to replace that with some controls, but the other thing is I also begin asking myself, why do we style tractors? You know, it's kind of I'm thinking in the future that some of this equipment becomes a metal framework that we hang technology on, as opposed to, and again, styling a tractor, beauty is in the eye of the beholder. There's no question about that. But if it's a utilitarian piece of equipment performing its function in the field and you no longer have a human operator on it, maybe some of the styling consideration goes away too. So just some things to think about in terms of how equipment, we might see it changing in the future.
Now, we talked a bit about soil compaction and larger tractors to be more efficient. You take that operator away, you can make those tractors a lot smaller, put more of them in the field. You run them more, you can run them pretty much 24/7, where at a certain point, the operator now has to stop and sleep. So where do you see the size going? What's the ideal size for a tractor?
Well, I think you're right in terms of your assertion that once we take the operator off the piece of equipment, all of a sudden, we may go back to the days of equipment sizes that are much smaller. And I think there's potential value in that in terms of looking at soil response to reduce gross weight of the vehicle. The optimum size, I think that's going to be an interesting one, but there's 2 or 3 things that I'm thinking about when we begin addressing that question of what the optimal size is. We see a host of autonomous tractors out there. A lot of them are concept vehicles, a lot of people kind of getting into the game, so to speak. A couple things that I think that are pretty true, though. I think part of what's going to happen, what's going to boil down to is there still needs to be a dealer's network to support this equipment. And that's going to be kind of a mainstay in some respects. So that's going to govern in some respects what we see happening in the future. In other words, there'll be some great startup companies, but unless they have the dealer networks, it's going to be hard for that equipment or those new concepts to penetrate the market in some respects. I'm not saying it won't happen, but I'm just saying there's a bit of a difficulty level there. Equipment size, kind of going back to that, if we take the operator off and we're no longer worried about that human element, and let's say we can have a human monitoring 6 or 7 tractors, I begin thinking about what reasonable equipment size is. And there's a couple different things that I think become important. As you take the operator off that piece of equipment, the question becomes, how do you get it between fields? Okay. And if we're going to move that equipment, let's say on trucks and trailers, it sure would be nice to load a piece of equipment without having to go to all kinds of lengths to prepare that piece of equipment for trucking it. And so what I'm really talking about is working widths of 10 feet or 3 meters. Depends upon whether you're in Europe or here in the US. But I think that becomes a pretty nice size in some respects in terms of transport width. When I begin thinking about soil engaging or tillage tools, if you will, and I'm thinking about that 10-foot working width, that really puts us in the 100 to 115, 120 horse category. Okay. And so that's where I think the sweet spot is. The reason why I like that 110, 120 horse category is you're still in 30-inch rows in case of a corn crop, and that means you're generally going to have a 60-inch wheel spacing. And when you think about undulating terrain and that tractor rocking back and forth, we've lived with that 60-inch wheel spacing for quite some time, and our systems are all set up for that. One of the things, I'm following Sabanta, which is a startup company in the Midwest, and Craig Rupp is the CEO of that company. But one of the things that Craig Rupp said was, I can get somebody without a CDL, a pickup truck and a gooseneck trailer, and he can move that equipment around that I'm talking about, the size being the 110, 120 horse. And he says it doesn't require a driver with a CDL. It gives us a lot of flexibility. And again, Sabanto has been automating that size of tractor, that kind of 10-foot working width, 110, 115, 120 horse. They're using Kubota M5s at this point in time. And so anyways, I've been watching Craig Rupp and his business, and I think it's one of those businesses that people want to probably pay some attention to, because I think Craig's got it about right in terms of how this automation might proceed in some respects. And one of the other terms, we can talk about this a little bit more, is farming as a service, which could change some of the ideas or some of the concepts of ownership of this equipment.
You start talking 110 horsepower. That reminds me, I spent a lot of hours driving an Alice Chalmers 7000, put a good many hours on that. And that's about 107, 108 horsepower tractor. We're back to where we were, I don't know, that's 40, 45 years ago, which I find somewhat amusing that we're going back to what we used to do.
Well, Mike, I like the fact that you brought up there's kind of some classic models of tractors. And over time, the John Deere 4020 as an example was one of those that was kind of the mainstay of agriculture for a long time. And that is about the size tractor we're talking about, 10 to 11,000 pounds, 100, 105, 110 horse. We might be slightly a little bit higher on horsepower, but it's going to change agriculture if we get to that point.
So if we have all of these different mechanizations and automations, you talked about a combine that was adjusting itself. How do we control all that? If it's not humans doing that, how does all of this get controlled?
Well, as we move forward, this whole area, and I'm going to use the term embedded controls, but we're putting microcontrollers, multiples on the pieces of equipment in the field. And at the end of the day, it's your ability to model these operations in the field and then create, if you will, computer code that controls the machine. One of the things that's coming, though, that I think is going to change the way we look at this automation scenario, and really is the sensing and control aspects of automation, is artificial intelligence. And we're just now seeing some products come into the marketplace. These products that have been introduced, I think what I'm going to say is they're game changers in terms of how we view crop cultivation. I'm going to point to John Deere See and Spray, but there's a couple other companies out there doing very similar. Green Eye is a technology out of Israel that's come into the United States now. But in these cases, they're marrying cameras with processors, and a lot of these are graphical processing units, GPUs, but they're putting those two technologies together, obviously using artificial intelligence in terms of the linkage, but they're able to go through the field. And in the case of John Deere and Green Eye, what they're looking to do is differentiate between weeds and the actively growing crop, whether it be corn, soybeans, wheat, or whatever, and then isolate or activate isolated spray nozzles to spray just the weed. Some of the reports from these companies are herbicide application rate reductions or material reductions of 70 or 80%. And that's a game changer in agriculture. Obviously, there's a cost to the technology, and I don't want to minimize that. And that technology has to mature too. But when you begin thinking about artificial intelligence and other aspects of agriculture where we might use it, there's going to be a lot of change. And again, what I go back to is we're replacing that human operator, and that human operator has been there to a large part to sense and control these operations. Well, now we have vision systems. Artificial intelligence can be applied in many other areas as well. So we look at the automation of the piece of equipment, that there's a lot of things that we can do. We can begin sensing things like vibration, which, by the way, the operator is on the piece of equipment to do that. Sound would be another one. And we begin applying artificial intelligence using some of these inputs. I'm not going to say we can replace the human yet, but we're not too far off.
Is your organization in need of funding? Trillium's Roots Community Fund is currently looking to provide money to projects for organizations in Ontario that are agriculturally focused. Applications are now being accepted for Ontario projects, including facilities or equipment upgrades, funding for research, innovation, and much more. To learn more about Roots, including how to apply, visit our website at trilliummutual.com and click Community at the top of the page. So if we've got the AI controlling, in the case of the See and Spray, controlling these individual plants, being able to target those, who makes the decision as to what the treatment is on that? Is that still in the hands of the individual farmer, or are we looking at someone else because we're writing code? Someone else is making those decisions.
Well, I think that's going to depend a lot upon how the industry sees this thing kind of unfolding and where it goes in the future. I'm going to present a scenario, though, that might be kind of interesting to think about. And I'm going to use an example here in the state of Ohio. We have a plant pathologist, Ann Dorrance, who is on our Worcester campus. And Ann is an extremely talented individual. She's dedicated her career to understanding diseases as they affect soybean crops in the state of Ohio. Okay. And hopefully you might see where I'm going with this. If you're an Ohio soybean farmer, they have a very high regard for Dr. Dorrance. And what I keep thinking to myself is, If a company can say to the farmers in the state of Ohio, we worked with Andorrance to develop the artificial intelligence on this machine to apply fungicides to a soybean crop selectively, I think that's going to go a long way. And so what I begin thinking about is, how do we take the most talented agronomists, soil fertility experts around the country? How do we get the most talented entomologists, the most talented plant pathologists? How do we take what's inside of their head and apply it through artificial intelligence to these machines that are in the field? And that's where I think things really get interesting. Certainly some of these products are coming to the marketplace, that there's a lot of engineering expertise involved in the development of these technologies. But I'm also thinking about, there's going to be a lot of other things that guide these decision-making processes where we have to ensure we're meeting certain thresholds to justify the application of some of these crop protectants. The big benefactors, certainly the environment, there's no question about that. I think because these technologies mature and adopted by agriculture, it's going to change the public perception of how agriculture is done. I also think, begin looking at the fertility side, there's some tremendous opportunities in terms of fertility management coming with these technologies. So I'm going to say, kind of hold on. It's going to be an interesting ride the next 10 to 15 years, because the one thing that will be constant is the rate of change in agriculture.
Yes, and we've seen a lot of change over the past 10 years as far as the technology that has been applied. Now, as a question, when we go into that, how long is the idea of this transition going to take, and what limits the idea of, well, we're going to change this? Farmers aren't going to change this overnight.
No, and there's also, when you look at artificial intelligence, it's still kind of in a black box stage. And so what do I mean by that? If you put an image into one of these graphical processing units, you will get a classification out, okay? I'm going to tell you right now, farmers, there could be a level of unease associated with that. In other words, I'm going to relegate all this control of these expensive herbicides and pesticides to this machine, and I'm going to trust that machine. So it's going to take a little while for agriculture to accept this. On the other hand, I'm going to tell you right now, profitability will drive a lot of this, and farmers are seeing significant reductions in their chemical costs and maintaining yields or improving yields. I think they're going to adopt the technology pretty quickly or pretty readily. Now, obviously, there's going to be a cost to the technology. One of the things, though, that I would like people to probably give a little bit of thought to is, there are going to be some of these AI applications, and I call them applications, maybe use cases might be a better term. Some of these things are going to be pretty easy. In other words, if I'm a farmer in Australia, for example, and I'm trying to conserve soil moisture, anything that's green and growing, I want to go ahead and spray it. And so that makes a lot of sense, and there's going to be a lot of systems that do that very readily. When it comes time, though, to distinguish between different diseases in soybeans and whether or not you spray, whether or not a threshold has been met in terms of the maturity of the crop, in terms of the involvement, in terms of disease, those models are going to take a little bit longer to evolve. And when I say models, it's really the intelligence you're putting on the machine that's going to recognize those differences. As we look at the life cycle of any crop in the field, the stage of growth is going to dictate, to a certain extent, what sort of management approach we're going to apply. Japanese beetles in soybeans, they will defoliate the plant, but really it's the threshold, has it been met in terms of how much defoliation and what stage of growth of the crop is at. And so as time goes along, I think these companies will come to the forefront and they'll figure out what these use cases are and how to develop the intelligence accordingly. But all that intelligence, at least with vision systems, is going to be driven by having databases of images that have been labeled and curated to support the training of these classifiers. At the end of the day, I think that's what's going to drive how quickly adoption occurs as we look to the future. In other words, different crops are going to require different models, classification models. Different maturities of the crops going to require different classification models. The corn and soybeans, they're easy ones. That's the 200 million acres in the Midwest. I think those will be the first that we'll see a lot of artificial intelligence used in. But then the question is how does it make it to some of these other crops? We get up into Canada, obviously we have the pulses, the small grains out in the western part of the US. And so it's going to be an implementation that's going to be driven by our ability to create these databases for training these models.
So we've kind of got the machine, we've kind of got the technology to control it there. you're still going to need some sort of connection back to your main office, or in order to control it, maybe the web. Is that going to be one of the major limitations, broadband access?
Mike, I think you've identified one of the things that probably should cause a lot of people lose sleep at night. I know when I look at some of these companies that are introducing technology to agriculture, it's going to be a major concern to them. The real issue is that connectivity in rural North America, and we struggle with it here in the state of Ohio.
Yeah, we do too, right up here.
It's tough. We know that there's a lot of focus on rural broadband here in the States. There are several funding streams, but largely it's left up to the local governments as to how they're going to implement some of these funds availability in terms of the build out of broadband connectivity. One of our major costs here in the US right now, oddly enough, is crossing interstate highways and railroads. And generally it's the engineering costs that make that a very expensive proposition. It's not just crossing with horizontal boring or directional drilling. The cost isn't all that significant, but again, it's the engineering cost and getting approval through the permitting process for that to happen. We have a lot of fiber optic going in rural Ohio, and that's a very good thing, but I want to remind everybody it's connecting the tractor to that fiber optic. And the question is, what is the technology that's going to be preferred there? We have Elon Musk deploying Starlink. That's a possible solution. The question is going to be bandwidth. In other words, how much data can I move and in which direction? The other thing that also becomes important as we begin controlling equipment autonomously in the field is something called latency. In other words, connecting to a cloud location somewhere, and that connection is required to keep that machine in the field and operating. The question is, how quickly can I send data back and forth? And so that latency becomes a big issue as well. One of the things, and I've been talking to some different organizations here in the United States, but one of the things that seems to be getting some traction right now are something that we call private 4G LTE or private 4G wireless networks. These are low power. The range on them is substantially reduced. My understanding is right now the FCC is allowing these in the US, that they're unlicensed, but the question is, are the cellular providers going to populate the rural parts of this country with 5G? Or is that going to take a while on that build out? And is it going to be up to farmers to establish their own networks, farmers and or service providers? I kind of liken this to the days of RTK correction for GPS. We've kind of gotten past that because a lot of that is provided by satellite signals now. But we also go back to a time where a lot of farmers were running their own base stations for GPS. And now GNSS, I want to be observant of the systems as we look around the world in different countries and satellite availability. But again, I think we're going to go through the same transition as we look to connect equipment in the field to the internet, and we make certain that that pipeline, if you will, for data is enough to support the operation of this equipment and also to move data back and forth. That's going to be essential as well.
So you obviously have a lot of passion for this and a lot of ideas about what we might see down the road. How did you get involved? How did this become something that is obviously a major interest of you?
I'm going to go back about maybe 10, 15 years ago and working with some graduate students. One of those individuals is Santosh Pitla. He's now a faculty member at the University of Nebraska. But we were kind of in the lab one day just talking about what if. And so his dissertation was on control architectures for autonomous equipment. And that's what really kind of started this whole thing. And it was a graduate student and myself just kind of thinking about, if this ever happened, what sort of things would we need to think about in terms of, and when I talk about the architectures, I'm talking about control architectures, but how would we support a swarm of vehicles? And I'll use swarm to denote at least 2 or more tractors in the field doing the same thing at the same time, or maybe equipment that would have to work cooperatively. And so we think about grain carts. If the grain cart's not underneath the unloading auger when the combine goes to unload, that's a problem. And as we begin thinking about automating equipment, we're going to have to coordinate the function of these. And so again, that happened 10, 15 years ago when I was at the University of Kentucky. And I started talking to farmers about this. And you can imagine me going into a room full of farmers talking about a swarm of vehicles 15 years ago. There were a lot of eyes rolling and a lot of people thinking that I was just plain nuts. Fast forward to today, I don't get that same reaction from farmers. They know this is a reality. They know this is coming. And so the question is going to be how quickly. A couple things to think about as I look at this transition, and if it is going to occur, how it occurs. I'm going to give the equipment manufacturers a lot of credit today. And I think when the majors, when they build a large high horsepower tractor, I think that tractor is going to have a life of 15,000 to maybe 20,000 hours. Okay. And that's pretty routine today. I don't think anybody would argue too much with me about that. Obviously, maintenance is going to be a big thing. But we look at some of these high horsepower tractors, at least in the Midwestern part of the US, they're used about 300 hours a year. Well, if you're starting to do the math, 300 hours a year and the tractor has a life 15,000 hours, you kind of get the feeling that the mechanical life of the tractor is going to far exceed maybe the technological life of the tractor. What do I mean by that? I use the cell phone as an example. I don't know about the rest of people or whatever, but I usually get a new cell phone every 2 to 3 years, and it's not because the old one quit working. It's because the new ones have more bells and whistles, more storage, more cameras, whatever the case may be. And so I'm just trying to get people to thinking about maybe that mechanical life and technical obsolescence ought to become more in line so that we've used up the mechanical life of the tractor about the time that it becomes obsolete and the next generation of tractor comes along. So I know that's kind of far-fetched, but we have probably the most modern fleet of agricultural machinery in this country that we've ever had. And I would assume that the same thing is going on in Canada. And so the question is, how long is it going to take that equipment to cycle through and for farmers to realize the full value of what they've purchased? So that's going to be part of what controls some of this. The other thing I think that's going to be important is, and I mentioned farming as a service, but I look to companies like Sabanto here in the United States. Another company I've been following very closely is Swarm Farm out of Australia. They've been doing autonomous sprayers. But in either one of these, I kind of put these companies in the category of farming as a service. In other words, a farmer is going to contract with them to seed a soybean field or spray a corn crop, whatever the case may be. Some of the numbers coming out of these companies, again, smaller machines. In the case of Sabanto, they're using Kubota tractors, but they're open operator stations. So I'm going to say very moderately cost pieces of equipment. In the case of Swarm Farm in Australia, they built an articulated sprayer. That's about a 30-foot boom on it, and that's about a 30-horse diesel engine, okay, and fully autonomous. But when I start looking at some of these and I hear some of the numbers coming out, these things are going to win out just purely based on economics. And we're not even beginning to think about what the impact may be in terms of alleviating a lot of the soil compaction we see. So do we start seeing increased yields when we go to smaller machinery complements? Do we address some of our labor problems? And does the overall cost of the equipment in the field, does that get reduced? The other thing to think about too is a lot of these operations become 24/7. So now what I'm able to do is amortize the cost of that piece of equipment, that capital asset. I'm able to amortize it over more acres. This farming as a service, in other words, people coming in and providing the spraying service, custom application would be an example of that. I think these companies might catch on, and there might be a different way of looking at how we do agriculture in many areas of the world.
Did we really miss anything that we need to talk about?
The one thing I did not talk about was how we're going to supply this equipment. It goes 24/7. Logistics. Everybody thinks you simply automate a tractor and you're done. Nope, that's not quite right. You got to refill it with seed, fertilizer, chemical, and fuel. And that has to go 24/7. When the tractor runs out of seed, it stops until you attend to it.
And the question there is, how much can we automate that particular aspect of what we do?
Well, and the other thing is, who's going to do that?
Yeah.
Is the farmer going to do it? Is the retailer going to do it? I spoke to Sunrise Cooperative here in the state of Ohio, and they just spent about $60 to $80 million in a lot of their facilities, upgrading those so they could load trucks 24/7, fertilizer, things like that.
Mm-hmm.
CEO said, he goes, I thought that we spent all this money, we caught up with where we needed to be. And then Dr. Shearer came in and just told me that we're behind again. So
It's the nature of technology, though. At a certain point, you just have to jump in with both feet and say, this is where it's going to be. Understanding that it may take 6 months to make the decision. It may take another year to get the equipment. In that 18 months, there are going to be advances that you're going to miss out on. And so that piece of equipment that you put in the field, it may already be, from a technological standpoint, it may already be obsolete by the time you've bought it.
Well, and one of the topics you've kind of hit on, a lot of these companies have focused on claiming IP, intellectual property, through the patent process. When the patent process takes 3 to 4 years,
Yeah.
marketplace has already moved on. So it's going to be interesting to see how these companies handle IP in the future as well.
Fascinating stuff.
Yep.
It is most definitely a fascinating topic. I'm very interested to see where all of this leads. Many years ago, when I was in university, we went on a trip down through the States, and I remember a farmer that we talked to there, and he had set himself a goal of buying 1 farm a year when he came out of school. And he said at that point, and that was back in 1985, he had succeeded in that. And he looked at us, and we're all 20, 21, and he says, I would take all that and give it back to see what's going to happen and be in your position to see what's going to happen in the next 30 years. And I really do think we're there. Scott, I want to thank you for taking the time to talk to us today. It's a fascinating topic.
Well, I've enjoyed this, and I'm going to agree with you. The next 20 to 30 years in agriculture, I think, is going to be pretty interesting. It'd be good to be alive at that point in the future and watch how those trends, and maybe some of my predictions became true, or in some cases, maybe I'm just plain nuts and it was never going to happen. But we're on the cusp, I think, of something pretty interesting.
I agree. I think that some of what you said is likely to happen. Some of it, maybe not. And some of it will happen based on information that we simply don't have yet, and new technology and new breakthroughs.
No question.
Thanks very much for joining us on the Back 40 today.
Well, thank you, Mike. I enjoyed the opportunity.
You've been listening to the Back 40. Sustainability in agriculture has become one of the buzzwords that we're very used to hearing. Join us next time when our guest will be Christophe Wand, the Livestock Sustainability Specialist with the Ontario Ministry of Agriculture, Food and Rural Affairs, and we'll talk about what sustainability will mean for agriculture both now and in the future. That's next time on the Back 40. You've been listening to the Back 40, brought to you by Trillium Mutual Insurance. Be sure to subscribe to the Back 40 wherever you find your favorite podcasts so that you don't miss an episode. The Back 40, bringing the ag community together one podcast at a time. I'm Mike Brine. Until next time, take care and stay safe.